So in preparation for 2024 code, I'm going to do some older problems just to get myself back in the swing of things. And I'm going to record them. I already started this one earlier, but I had trouble with the second half. So I'm redoing it. Hopefully it'll go better this time. Anyway, this is year 2020. You can see all of the events here. In this account, I haven't done very much. In particular, I just started 2020 this morning. In another account, I have done some of 2020, but it was in 2020, so it was a long time ago, and I don't really remember. Anyway, this first puzzle, you're supposed to have an expense report with these numbers, and the numbers represent different expenses. And you are supposed to find two entries that sum to 2020. And once you find two such entries, you want to multiply them together and return that as your answer. Now, in this little sample, it says the numbers that sum to 2020 are 1721 and 2099. And when you multiply them together, you get 50, 514, 579. So that's the answer for this little test. However, you have puzzle input, which is down here, and that's the real thing. As we said, I started it this morning and I typed in the answer already, which is why this thing is here and incorrect. But I'm going to show you exactly how I did it. So I'm starting up in Emacs. This is a Windows 10 machine. I hope the Emacs actually started. I have this thing over here that shows mouse clicks and type in as I'm doing it. So the first thing I want to do is I want to open up a file. I have a new AOC folder, and I'm going to do aoca2020 day 01.el for eLisp. That's what I'm doing. Now I have a little function, aoca, where you give it the year, the day, and whether or not to insert a template into your buffer, which is what I like to do. And so this allows me to quickly, fill in some things that you need. I'm going to put sample input here, the real input here. If there's separate part 2 inputs, samples, so that would go here. And then this is where I'll define a function to do part 1, and these are ways to test it. So this is an invocation of this not yet written function on the sample input, and this is an invocation on the real input. So the first thing I need to do is I need to get the input and the sample. So here's the sample. I've highlighted. I can copy the sample. I can paste. I thought I highlighted it. Does look highlighted. I'll say copy here. Now I should be able to say paste. Why does that not work? Clear. Paste. So not doing it for the menu. This the Windows copy paste buffer can get the strange states if there's something pushed onto it. So anyway, I'm assuming that's what it was. And then the next thing that I need to do is I actually need to go down to the end and get my public input. Control A, Control C. Hopefully the copy works this time. Into here. Control Y to paste it. So the first thing that I have to do is the def-r in Lisp defines a variable. The variable has asterisk around it to show that it's a global variable, and all Lisp constructions are lists. That is, they're enclosed in parentheses. Control meta A goes to the end of an expression. Control X, Control E will evaluate that expression. And so we've now defined the contents of the variable aoca2020 input. Then I can go Control Met F to go forward another expression, Control X, Control E again. We don't have a second sample, so I'm just going to go twice in front. I do need to evaluate this. This brings in some Common Lisp compatibility stuff. And this is a setting for Emacs that allows Control G, which normally aborts what you're doing, to instead go into the debugger so you can see what it's doing, and especially if it's something that's long running and making progress, you can then continue rather than having to just throw away all the work you did. So the first thing we need to do, let's go back to here, and to the top of the screen with Control 0, Control L. Control L normally recenters the screen, but you can give it numeric arguments to slightly change its behavior. So Control L would put the line with the cursor in the middle of the screen. Control 0, Control L puts that line in the top, and Control -1, Control L will put it at the bottom. So first we need to So 99, one of the reasons I use the Common Lisp competitively vector, which is to use the loop macro, and one of the, so 99% of my functions for advanced code are just invocations of the loop macro. So I'm going to say loop with numbers, the with clause in the loop macro defines a variable that has the scope of the entire loop. And what I'm going to set it to is calling map to produce a list of, and the map will take a function. If you look down at the bottom, you see that it says the type of the result and the function and then the sequence that we're going to map over. So what I'm going to string to number is a built-in elisp function. So we're going to apply that function to each number in the sequence. And then the sequence is going to be split string, which is another built-in Emacs function of our input string, which is the first argument. And we're going to split it on the lines. So notice each number goes to a new line. So each one we have a split string will have a list of strings, and then we're going to call string to number on each one of those and collect the results into a list. And so here we'll have a list of numbers. So we're going to loop for n in numbers. When you there's many different kinds of iteration styles that you can use, but for n in numbers means you're going to go down the list, and each time through the loop, n will become, take the value of a successive member of the list. So what we need to do is we need to find out what other number in the list sums to 2020. So for needed equals minus 2020 n. So that's the number that we have to look for. And for found, because we're going to call the Common Lisp function position, which takes an item to look for, namely the needed number, in a sequence, namely the numbers list, and returns the index of that position, or nil if it doesn't find one. So when found, we're supposed to return the result of multiplying the two numbers together, the original number and the one that makes it add up to 2020. So return times n needed, and that's it. So Control Meta E again goes to the end of the expression. Control X, Control E will compile it. Control Meta F goes to the whole next expression, but these are comments, so Emacs skips over the comments when you do that. But I can do this. Now I've captured that expression. You can just evaluate it. You can just say Control Meta and then put that expression in there, and then you'll get an answer out. But you can also, just like giving a numeric argument to control L will change its behavior. You give a new argument, numeric argument to metacolon, you can do the same thing, but now what it'll do is it'll insert the result into the buffer. So now we have a record of what the result was. And if we go back to the, sorry, that's my input, I'll get rid of that. We go back to the description here with the sample 514579, and that's exactly what we got. So this time, I'm going to actually execute it on the real data, and the answer is 1015476, and that's what I typed in before. That's the correct answer. So, as I said, I had done this before. I got bollocksed up and interrupted several times, so that's why I'm doing it over again. The second half is to say the elves are going to give you a bonus if you can, instead of finding two numbers that add up to 20, find three. With many of these advent of code things, the second part is a variation on the first part, often harder. So I'm going to copy this entire thing so we can see what differences we have later. So control meta, forward. So one of the cool things about Emacs is control F is go forward a character, meta F is go forward a word, and control meta F is go forward a whole expression. Similarly, control B is back a character, meta B is back a word, and control meta B is backwards a whole expression. You can also do control meta U, which goes up a level. You can do control meta K to kill a whole expression. All sorts of things. So adjust function above adjusted for the second part. So one of the usual ways that I do this is I add an optional argument, part 2. And so now inside the body of the function, you can test for whether you're doing part 2 or you're not doing part 2. An optional argument has the value nil, which is the false value for Lisp. Any non-nil value is true in conditionals. And so we're going to use, and then down here, what I usually do is I just invoke part 1 with input string and set the part 2 to true. And this is an optional argument. If you don't supply it, it's nil. So even though I've said, and then I can just define this, and now I have my part 2 function, which is really calling the part 1 function, but with a different set of arguments, slightly different. Now, it is a little bit tricky, which is why I had problems first. We need to actually distinguish several cases, and we need to do an optimization. The first thing we need to do is that here we have a constant that we're using to see how much away from our desired number we are. That has to turn into a variable. So we have another option that, optional argument, rest needed. And so what we can do here is you can say or rest needed 2020, which means that if rest needed is nil, the default on the first case, we're going to use 2020, otherwise we'll use rest needed. Then the second thing we want to do is we want to actually not have to parse this list of numbers each time. But we're going to, the basic plan is to call the top level to loop through all the numbers, but then we're going to call ourselves recursively once again to see if we can find two numbers that add up to the new target. So I'm going to have a numbers list here, which again defaults to nil. So what we're going to do is up here, or numbers list. So if we pass in a numbers list, we don't have to do the string to numbers, split string, bring row. Now, all of this is pretty much the same, except that now this is only what we return if we're in part one. In part two, we want to find the next two numbers that we need. So we're going to basically do the same thing as part one, but with a different target. So for next two numbers equals, and we only do this in part two, and we call ourselves with the input string, which we're not going to get to use, but we actually call it null. We're also going to call the recursive one without part two because we don't want to keep recursing indefinitely. But we do want to say that what we need is needed here. This is the target that we're looking for, and we want the numbers that we passed in as a list of numbers, not as a string with new lines that you have to split apart each time. Now, we have to return a different thing because if we're in the recursive place, we need the two numbers that we found that add up to the new target. So if part two, we're going to call list of n needed as the return value. Otherwise, we're going to do the part one thing, which is multiply the two together. Right. Except that we still need to do one more thing, which is we need to multiply all the numbers together. So we're going to keep looping until so in the first case, when it was just part one, we either get the member of the list that completes the sum to 2020, or we don't get anything, in which case the loop will return nil. But it's just a one deal. We go through the numbers once. However, in this part two case, we might find we might have other possible matches that don't solve the problem. So we have to make sure that this is when and found not part two. Remember, part two is set for this top level. It's not set in the recursive call. So in that, when we're in here, if we found an answer that completes as a single one, but we're not in part two, we're going to return this. And then if we are in part two, nope, it's not part two here. This is simply if we need a different value. This one is when and part two, next two numbers. Our next two numbers could be nil. So then this thing, then we're going to return times n, which is the number we're checking. So actually we're going to say apply multiply to n next two numbers. And we should be done. That completes the loop. Control meta U goes up a level, control meta F. You have to find it. So first thing we want to do is we redefined aoca 2021 part 1, so we want to make sure that we still get the same answers. And indeed we do, for that one, and that one, because we're invoking it with part 2 set to nil. And then here we want to make sure that we get a different answer. In the problem, it says the three numbers in the sample that are 969, 366, and 675, and then when you multiply them together, you get this 24,186, 1950 number. Let's see, do we get that? Whoops. So my template assumes that you're going to use part 2 sample for part 2 testing, but we don't have a part 2 sample, so we're going to just do it. So I changed it to part 1. And in fact, we got the 24,186, 1950. And now we're going to do the same thing on the real input. And that's the answer, we believe. We can check it. And it is indeed the answer. So, sorry about having to redo the first part. But one of the advantages of doing it in Emacs Lisp is that you have a lot of interactive ways to check what's going on and debug. And I'm sure in some of the future videos we'll see that. Thanks for your attention.